Good afternoon, students. So let us begin with today's class. We are discussing moving charges and magnetism. Okay, so in the moving charges and magnetism, here mainly we will deal with the magnetic force, motion in a magnetic field, then motion of a conductor in a combined electric and the magnetic field due to the current element, that is nothing but the Biot-Savart law. And we discuss about the Ampere's circuital law, the solenoid toroid force between the two parallel current, torque, ಈ ತರ expressions ಅನ್ನ ನಾವಿಲ್ಲಿ deal ಮಾಡ್ತೀವಿ. So if you want, first we will see the formula list, then we will begin with the class. Okay. So here, what is magnetic force? Magnetic force is nothing but what? Whatever the force exerted by the magnet around it, that is called as the magnetic force anta ಹೇಳ್ತೀವಿ. Here, the magnetic force is given by the magnetic force due to a charge is given by. So magnetic force due to a charge is given by. You can write the formula. F is equal to the magnetic force due to the charge is given by F is equal to QVB anta ಹೇಳ್ತಾರೆ. Okay. Then here the Lorentz force anta study ಮಾಡ್ತೀವಿ. What is Lorentz force? Lorentz force is nothing but it is the combined force due to the magnetic field and due to the electric field. The expression is for the Lorentz force is given by Q ಅನ್ನ ಹೊರಗಡೆ ಇಟ್ಟು we write E plus V cross B. So first force what you are writing, this is the electrostatic force first, then the second one is the magnetic force. Okay. And now here the unit for the magnetic field is Tesla anta ಹೇಳ್ತೀವಿ. And the other unit is Gauss. What is the relation between this Tesla and Gauss? That is 1 Gauss is equal to, we write 1 Gauss is equal to 10 to the power of -4 Tesla anta ಬರಿತೀವಿ. Okay. Then after this we have, when the charged particle is moving in a circular path, what is the expression for the radius of the circle? The radius of the circle is given by, it is mv divided by qb anta ಹೇಳ್ತಾರೆ. Okay, or else we can write it in terms of momentum also, because mass into velocity is momentum of upon q into b. We can write in terms of energy also, that is under root of 2mk divided by qb. And the time period of the charged body moving in a circular path is given by t is equal to 2 pi r upon v anta ಬರಿತೀವಿ. We also write it as what? 2 pi divided by v into mv divided by qb. We can also write 2 pi m divided by qb. So note down this formula. ಮತ್ತೆ frequency ಅಂದ್ರೆ reciprocal of time period ಆಗತ್ತೆ. Note down this, then I'll tell you the next formula. Okay, for the frequency, what you need to do, the frequency is given by what? That is, the frequency is equal to QB divided by 2 pi m. Time period is 2 pi m upon QB, and frequency is reciprocal of that. Then the angular speed is given by, so the angular speed is given by For the charged particle moving in a circular path, that formula I am telling. Okay, that is omega is equal to QB divided by m. So note down this formula, students, which will help you to solve the problems. Okay, so ಈ ಕಡೆ ರೇಡಿಯಸ್ ಎಲ್ಲ ಕಂಪ್ಲೀಟ್ ಆಗಿರಬಹುದು ಅಂತ ಅನ್ಕೊಳ್ತೀನಿ. I'll clean this and I'll write the next formula. Okay. So if the charged particle is moving in a helical path, if the charged particle is moving in a helical path, ಅಂದ್ರೆ ಈ ತರ ಏನಾದ್ರೂ ಮೂವ್ಮೆಂಟ್ ಆಗ್ತಾ ಇದ್ರೆ, that time the radius of the helical path is given by, the radius of the path is given by, it is mv sin theta divided by qb. mv sin theta divided by qb. In that case, the time period is given by 2 pi r divided by v sin theta ಅಂತ ಬರಿತೀವಿ. ಸೊ ನೀವು ಇಲ್ಲಿ ಏನ್ ಮಾಡಬಹುದು, r value ಅಂದ್ರೆ ರೇಡಿಯಸ್ ವ್ಯಾಲ್ಯೂ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿ, the time period can also be written as what, 2 pi m divided by qb. 2 pi m divided by qb ಅಂತ ಕೂಡ ಬರಿಬಹುದು ಇಲ್ಲಿ. ಓಕೆ, so take down this formula. Similarly, the kinetic energy is calculated by using the formula. The kinetic energy is equal to q square b square r square divided by 2m. q square b square r square divided by 2m. Is completed. So ಯಾವ ಟರ್ಮ್ ಅರ್ಥ ಆಗಲ್ಲ ಪ್ಲೀಸ್ ಕೇಳಿ. ಹೋಪ್ ಸೊ ನಿಮಗೆ ಟರ್ಮ್ಸ್ ಮೀನಿಂಗ್ ಗೊತ್ತಿದೆ ಅಂತ ಅನ್ಕೊಳ್ತೀನಿ. Q is charge, B is magnetic field, M is mass. Okay, the terms are having the usual meanings. If you don't understand any term, please tell. Is completed, students? Okay, so the next one, according to Biot-Savart law, the magnetic field is given by, that is dB is equal to mu naught upon 4 pi I dl cross r divided by r cube. Okay, so suppose if you want the value of mu naught upon 4 pi ಎಷ್ಟಿರುತ್ತೆ ಹೇಳಿ? What is the value of mu naught upon 4 pi? Yes, anybody knows what is mu naught upon 4 pi? It is 10 to the power of minus 7. 10 raised to minus 7. Okay, then now according to the Ampere's circular law, we can write the line integral is equal to the line integral of product of magnetic field and the area is equal to mu naught times the current flowing through the given circuit. Then one more, the last formula. The force between the two parallel currents is given by, it is F is equal to mu naught I1 into I2 divided by 2 pi into D. Mu naught I1 into I2 divided by 2 pi into D. Now let us start with the questions. Hope so you have completed all the formulas. Yes. Yes, students. So here we have the first question. When iron fillings are sprinkled around the current carrying wire. So iron ಏನಾಗ್ತಾ ಇದೆ, that is iron fillings ಅನ್ನ current carrying conductor ಸುತ್ತಲ ನೀವು ಹಾಕಿದಾಗ ಏನಾಗತ್ತೆ ಅಂತ ಕೇಳ್ತಾ ಇದ್ದಾರೆ. You can see the four options and tell me which is the correct option. Yes. When the iron fillings are sprinkled around the current carrying wire, they arrange themselves in concentric circles with the wire as the center. They reveals the pattern of the magnetism around the wire. The field lines are more concerned near the center, all of this. Questions are not visible. PPT is visible or no, students? Once again, I'll share. One second. Yes, now you see. Yes, okay. Okay, yes. Okay, now you read and tell me the answer. Okay, formulas, 1 second. I'll complete some questions, then after that I'll display. Yes, option D is the correct answer. So go for the next question. The next question is the laws obeyed by electricity and magnetism were uniformed and formulated by J.C. Bose, James Maxwell, Marconi, Oersted. B. Yes, correct. Very good. So it was combined by the Maxwell in the year of 1964. The next question, students. When a magnetic compass needle is carried nearby to a straight wire carrying current, then the straight wire causes a noticeable deflection in the compass needle. First statement. Second statement is what? The alignment of the needle is tangential to an imaginary circle with a straight wire as its center and has a plane perpendicular to the wire. So question ಅಲ್ಲಿ ಏನ್ ಹೇಳ್ತಾ ಇದ್ದಾರೆ ಅಂತಂದ್ರೆ when a magnetic compass needle is carried near by a straight wire carrying current. ಸೊ ನೀವೇನ್ ಮಾಡ್ತಾ ಇದ್ದೀರಾ, ನಿಮ್ಮ ಹತ್ರ ಒಂದು ಕರೆಂಟ್ ಕ್ಯಾರಿಂಗ್ ಕಂಡಕ್ಟರ್ ಇದೆ or wire ಇದೆ, you are bringing the compass needle near to that. ಹೌದಾ? ಅವಾಗ ಏನಾಗುತ್ತೆ? The straight wire cause a noticeable deflection in the compass needle. So compass needle ಅಲ್ಲಿ deflection ತೋರಿಸುತ್ತೆ. Second statement, the alignment of the needle is tangential to an imaginary circle with straight wire as its center and has a plane perpendicular to the wire. So A, B, C, D. ಎರಡು ಕರೆಕ್ಟ್ ಆಗಿದೆಯಾ ಅಥವಾ ಓನ್ಲಿ ಫಸ್ಟ್ ಸ್ಟೇಟ್ಮೆಂಟ್, ಸೆಕೆಂಡ್ ಸ್ಟೇಟ್ಮೆಂಟ್? ಸಿ, both are correct. Yes, very good. So both the statements are correct here. Go for the next question. Which of the following is not correct about the Lorentz force? ನಾನು ನಿಮ್ಗೆ ಈಗಷ್ಟೇ Lorentz force ಹೇಳಿದ್ದೆ. ಸೊ ನಿಮಗೆ ಫಾರ್ಮುಲಾ ಬೇಕಂದ್ರೆ ನಾನು ಈಗ ಮತ್ತೊಂದ್ಸಲಿ ಸ್ವಲ್ಪ ಕ್ವಶನ್ಸ್ ಕವರ್ ಆದ್ಮೇಲೆ ಲಾಸ್ಟ್ ಅಲ್ಲಿ ಡಿಸ್ಕಸ್ ಮಾಡೋಣ. The next is regarding the Lorentz force. What is Lorentz force? Lorentz force is the combined force ಅಂತ ಹೇಳ್ತೀವಿ. That is due to the electric field and due to the magnetic field ಇರುತ್ತೆ. ಹೌದಾ? Which of the following is not correct about the Lorentz force? In presence of the electric field and magnetic field, the force on a wire, the force on a moving electric charge is F is equal to equation ಕೊಟ್ಟಿದ್ದಾರೆ. Second ಅಲ್ಲಿ ಏನು ಹೇಳ್ತಾ ಇದ್ದಾರೆ? The force due to magnetic field on a negative charge is opposite to that on a positive charge ಅಂತ ಹೇಳ್ತಾ ಇದ್ದಾರೆ. C, the force due to magnetic field becomes zero if velocity and magnetic field are parallel or anti-parallel. For a static charge, the magnetic force is maximum. Which is not correct ಆಯ್ತಾ? So first ಅಂತೂ correct ಆಗಿದೆ. Option D ಯಾ? Okay. Yes, very good. If a charge is not moving, then the magnetic force is zero. So why? You can see here. Because velocity zero ಆಗತ್ತೆ, ಅವಾಗ magnetic force zero ಆಗತ್ತೆ. So therefore option D is the correct answer. For a static charge, the magnetic force is maximum. Because electric force zero ಆಗತ್ತೆ. So electric force zero ಆದಾಗ magnetic force will be maximum. Go for the next question. In an interval frame of reference, inertial frame of reference, the magnetic force on a moving charged particle is F. Its value is another inertial frame of reference will be. So what is the meaning here, students? First name inertial frame andre ಗೊತ್ತಿರಬೇಕು. ಯಾರಿಗಾದ್ರೂ ಗೊತ್ತಿದೆಯಾ what is inertial frame? So we have two frames of reference. Inertial frame of reference and the non-inertial frame of reference. Inertial frame of reference anta andre where the Newton's laws are obeyed. So ಎಲ್ಲಿ Newton's laws obey ಆಗತ್ತೆ, that is called as the inertial frame. Where the Newton's laws are not obeyed, that is called as the non-inertial frame of reference ಅಂತ ಹೇಳ್ತಾರೆ. So ಇಲ್ಲಿ question ಏನ್ ಕೇಳ್ತಾ ಇದ್ದಾರೆ? In an inertial frame of reference, the magnetic force on a moving charged particle is F. So on the moving charged particle, the magnetic force F anta ಇದೆ. Its value is another inertial frame of reference will be remained same, changed due to change in the amount of the charge, changed due to change in the velocity of the charged particle, changed due to change in the field direction. ಸೊ ಮತ್ತೊಂದು ಇನರ್ಷಿಯಲ್ ಫ್ರೇಮ್ ಅಲ್ಲಿ ಅದ್ರ ವ್ಯಾಲ್ಯೂ ಏನಾಗತ್ತೆ? ಸಿ, ಎಸ್ ಕರೆಕ್ಟ್, ವೆರಿ ಗುಡ್, ಕರೆಕ್ಟ್. So see, that is nothing but QVB sin theta. So that is the change due to the change in the velocity of the charged particle. So ಮತ್ತೊಂದು inertial frame ಅಲ್ಲಿ ಹೋದಾಗ ಅದ್ರ velocity change ಆಗೋದ್ರಿಂದ the force value changes. Force ಕೂಡ change ಆಗತ್ತೆ. Yes, the next question. The magnetic force F on a current carrying conductor of length L in an external magnetic field B is given by. The magnetic force F on a current carrying conductor of length L in a magnetic field B is given by. C, yes, it is correct answer. So the magnetic force F on a current carrying conductor is given by I is equal to, into bracket L cross B. Option C is the correct answer. Go for the next question. A straight wire having mass 1.2 kg and length 1 meter carries a current of 5 ampere. If the wire is suspended in mid-air by a uniform horizontal magnetic field, then the magnitude of field is. So magnetic field value ಕೇಳ್ತಾ ಇದ್ದಾರೆ. You have to calculate the magnetic field. Current is given, mass is given, length is given. Calculate the magnetic field. Yes. So here the magnetic field is given by C. Okay, let's see what is the answer. Okay, for the mid-air suspension, the magnetic field caused is given by IBL. Okay, so this is IBL. And this magnetic field is balanced by, it is balanced by the gravitational force. It is balanced by the gravitational force that is given by mg, or the weight of the wire. So therefore, now what we can do, this we can equate these equations. We can equate these equations. So therefore, IBL is equal to m into g. Therefore, B is equal to mg divided by I into L. So where m value is given, students, 1.2 kg anta ide. G value acceleration due to gravity 10 anta tagoli. I value is 5 ampere. L value is 1 meter. So if you substitute, if you simplify, 5 ones are 5 twos are 10. 1.2 into 2. It is nothing but what? 2.4 Tesla. Option C is the correct answer. Is option C. Let us go for the next question. Yes. Take this question. A 2.5 meter long straight wire having mass of 500 gram is suspended in mid-air by a uniform horizontal magnetic field B. If a current of 4 ampere is passing through the wire, then the magnitude of the field is. Yes, a 2.5 meter long straight wire having mass of 500 gram. ಸೊ ಮಾಸ್ ಎಷ್ಟಿದೆ 500 ಗ್ರಾಮ್ ಇದೆ 500 ಗ್ರಾಮ್ ಇರೋದನ್ನ ನೀವು ಕೆಜಿ ಕನ್ವರ್ಟ್ ಮಾಡ್ಬೇಕಾಗತ್ತೆ ಸೊ therefore it is 0.5 kg the current value is given the current value is 4 ampere and the length is given it is 2.5 meter we need to calculate the magnetic field magnitude of the magnetic field. So again same that is mg is equal to IBL therefore B is equal to it is mg divided by I into L. What is mass? Mass is 0.5 kg into acceleration due to gravity is 10. Current is 4 and the length is 2.5. Yes. Option A. Yes, correct. Yes, very good. Other students? Option A correct. Yes, option A is the correct answer. Okay. Copied everyone? Option A is the answer. Go for the next question. A current of 10 ampere, is flowing in a wire of length. So wire of length, it is 1.5 meter and the current is given as 10 ampere. A force of, so force is 15 Newton acts on it when it is placed in a uniform magnetic field. So the magnetic field is given as 2 Tesla. The angle between the magnetic field and the direction of the current is, we need to calculate the angle. So as we know that the magnetic force is given by ILB or BIL sin theta, bill anta kuda ನಾವು ನೆನಪಿಡ್ತೀವಿ ಇದನ್ನ. So BIL or IBL sin theta, we need to calculate the angle. So therefore sin theta is equal to formula will be F divided by ILB. F is how much? It is 15 divided by, this is 10 into 1.5 into it is 2, which is equal to sin theta. Option A, yes, correct. So nodi, this is 15 divided by 10 into 1.5. ನಿಮ್ಗೆ ಸಿಂಪ್ಲಿಫೈ ಮಾಡ್ಲಿಕ್ಕೆ ಬರ್ಲಿಲ್ಲ ಅಂದ್ರೆ 15 by 10 ಅಂತ ಮಾಡ್ಕೊಳ್ಳಿ, ಆ 10 ಮೇಲ್ಗಡೆ ಹೋಗುತ್ತೆ into 2. So 15 cancel ಆಗುತ್ತೆ, 10 cancel ಆಗುತ್ತೆ. You are left with what? 1 by 2 is equal to sin theta. So sin theta is equal to 1 by 2. Therefore theta is equal to ಎಷ್ಟಾಗುತ್ತೆ students? It is 30 degree. Correct? Is it clear everyone? Go for the next question. The horizontal component of Earth's magnetic field at a certain place is 3 into 10 raised to minus 5 Tesla and having a direction from the geographic south to geographic north. The force per unit length on a very long straight conductor carrying a steady current of 1.2 ampere in east to west direction is. Yes. See what they are asking. The horizontal component of Earth's magnetic field is given. That is 3 into 10 raised to minus 5 Tesla and having a direction from the geographic south to geographic north. the force per unit length on a very long straight current conductor carrying a steady current of 1.2 ampere in east to west direction is. So suppose if I take this F by L as a small f ಅಂತ ತಗೊಂಡ್ರೆ ನಮ್ದು ಫಾರ್ಮುಲಾ ಏನಿದೆ ಇದು IBL sin theta ಅಂತ ಇತ್ತು. F is equal to IBL sin theta ಅಂತ ಇತ್ತು. ಹೌದಾ? ನಾನು ಇದೆಲ್ಲನ ಈ ಕಡೆ ತಗೊಂಡ್ರೆ ಉಳಿಯತ್ತೇನಿಲ್ಲಿ IB sin theta ಅಂತ ಉಳಿಯುತ್ತೆ. F by L is equal to IB sin theta. So therefore the small f is equal to IB sin of 90 degree. Correct? Because geographic south and geographic north anta specify ಮಾಡ್ತಾ ಇದ್ದಾರೆ. So the angle will be 90 degree. And here it is 1.2 into B is 3 into 10 raised to minus 5. Sin 90 is 1. So 1.2 into 3 is nothing but what? 12 to 3 is 36. ಹಾಗಾದ್ರೆ 3.6 into 10 raised to minus 5 Newton per meter ಅಂತ ಆಗುತ್ತೆ. Because force is Newton per unit length ಅಂತ ಅಂದ್ರೆ per meter ಅಂತ ಆಗುತ್ತೆ. Yes, option C is the correct answer. Yes, I'll give you 1 minute. Copy down the question and answer. Then we will go to the next question. Okay. Go for the next question, students. The magnetic force per unit length on a wire carrying a current of 10 ampere and making an angle of 45 degree with the direction of a uniform magnetic field of 0.20 Tesla is. So again, you need to calculate force per unit area. Sorry, force per unit length. So therefore, force per unit length is equal to IB sine of making an angle of 45 degree. Okay. So therefore, I value is, the current value is 10 ampere. The magnetic field is 0.20 Tesla. Sine 45 is 1 divided by root 2. It will be option. Yes, very good. Option B is the correct answer. Option B. Sorry. That is 2 divided by root 2. It is 2 divided by root 2 Newton per meter. Yes, copied. So same question. So I'm going for the next question now. Yes, the next question is a circular coil of 20 turns and 10 centimeter radius is placed in a uniform magnetic field of 0.10 Tesla, normal to the plane of the coil. If the current of the coil is 5 ampere, cross-sectional area is 10 raised to minus 5 meter square, and the coil is made up of copper wire having free electron density about 10 raised to 29 per meter cube. Then the average force on each electron in the coil due to magnetic field is. So ಏನೇನ್ ಕೊಟ್ಟಿದ್ದಾರೆ ಅಂತ ನೋಡಿ ಇಲ್ಲಿ ಕ್ವಶನ್ ಅಲ್ಲಿ. See, a wire, a circular coil, 20 turns. Number of turns is given. 10 centimeter radius is there. So radius is there. Number of turns is there. Is placed in a uniform magnetic field. So the magnetic field is there, normal to the plane of the coil. If the current in the coil, so this is the current in the coil. This is the area. And the coil is made up of copper wire having free electron density. So number of free electron density is also given, that is 10 to the power of 29 per meter cube. Then the average force they are asking. Then they are asking the average force. Okay. So see what we can do here antandre. As we know that the current and the drift velocity relation, that is current is equal to NEA VD. We can also write EVD is equal to E into VD is equal to I divided by N into A. So the force on the each electron is given by, the force on the each electron is given by, it is EVD into B is equal to, what is nothing but I divided by N into A into B. So this is nothing but what? QVB sine theta. So QVB anta andre enu, that is the force on the charge. Therefore F is equal to ಏನಾಗುತ್ತೆ ಇದು IB divided by N into A ಅಂತ ಆಗುತ್ತೆ. So what is I value? I value is 5 ampere. Then B value is 0.10 Tesla divided by N, that is 10 to the power of 29, the number of density, into area. So area is 10 raised to minus 5. Option B. Yes. Option B is the correct answer. Yes. Understood. Copy down the question and the solution. We will go for the next question. Copy down. ಸೊ ನೀವು ಈ ತರಾನೇ ಯಾಕೆ ಮಾಡಿದ್ವಿ ಅಂತ ಹೇಳಿ ನೀವು ಕೇಳಬಹುದು ಸ್ಟೂಡೆಂಟ್ಸ್. ಬಿಕಾಸ್ ಸಪೋಸ್ ಅಲ್ಲಿ ಏನಾದ್ರು ಕಂಡಕ್ಟರ್ ಅಂತ ಅವ್ರು ಸ್ಪೆಸಿಫೈ ಮಾಡ್ತಿದ್ರೆ ದ ಫಾರ್ಮುಲಾ ವುಡ್ ಬಿ ಎಫ್ ಇಸ್ ಈಕ್ವಲ್ ಟು IBL ಅಂತ ಬರ್ಬೇಕಿತ್ತು. ಅವಾಗ ನಾವ್ ಇದ್ರ ಬಗ್ಗೆ ಥಿಂಕ್ ಮಾಡ್ತಿದ್ವಿ. ಬಟ್ ಅವ್ರು ಏನ್ ಹೇಳಿದ್ದಾರೆ, ದ ಫೋರ್ಸ್ ಆನ್ ದ ಇಲೆಕ್ಟ್ರಾನ್ ಅಂತ ಹೇಳಿದ್ದಾರೆ. ಸೊ ಫೋರ್ಸ್ ಆನ್ ದ ಚಾರ್ಜ್ ಇಸ್ ಗಿವನ್ ಬೈ ವಾಟ್? QVB. ಹೌದಾ? ಸೊ QVB ಎಲ್ಲ ನಮ್ಗಲ್ಲಿ ಕೊಟ್ಟಿದಾರ ಇಲ್ಲ ಅಂತ ಹೇಳಿ ನೀವು ನೋಡ್ಬೇಕು. ಬಟ್ ಇಲ್ಲಿ ಕರೆಂಟ್ ಎಲ್ಲ ಇದೆ, ಚಾರ್ಜ್ ವ್ಯಾಲ್ಯೂ ಕೊಟ್ಟಿಲ್ಲ. ಸೊ ಹಾಗಾಗಿ ಕರೆಂಟ್ ಇಂಟು ಇದೇನ್ ವೆಲಾಸಿಟಿ, ಇದನ್ನ ನಾವ್ ಇದನ್ನ ಏನಂತ ಕನ್ವರ್ಟ್ ಮಾಡಿದ್ವಿ, ದಿಸ್ converted into I divided by NA into EB ಅನ್ನ as it is ಇಟ್ಟಿದ್ದೀವಿ ಅಷ್ಟೇ, ಮತ್ತೇನಿಲ್ಲ ಆಯ್ತಾ. Yes, completed. Okay, let us go for the next question. That we will solve at the end. So take this. Which of the following is correct statement about the magnetic forces? Magnetic forces always obey Newton's third law. Magnetic forces do not obey Newton's third law. For very high current, magnetic forces obey Newton's third law. Inside low magnetic field, magnetic forces obey Newton's third law. It is option C. Okay, it is option B. Magnetic forces do not obey Newton's third law. Option B is the correct answer. So going for the next question. Question number 16. A charged particle is moving on a circular path with velocity v in a uniform magnetic field B. If the velocity of the charged particle is doubled and the strength of the magnetic field is reduced to half, then the radius becomes, ನಾನು ನಿಮ್ಗೆ already radius ಬಗ್ಗೆ formula first ಅಲ್ಲೇ ಕೊಟ್ಟಿದ್ದೆ. Okay, so ಏನಾಗತ್ತೆ radius ಗೆ ಅಂತ ಕೇಳಿದರೆ, radius is equal to the formula is mv divided by qb ಅಂತ ನಾವು first ಅಲ್ಲೇ ನೋಡಿದ್ವಿ. So here see ಏನಂತ ಹೇಳ್ತಾ ಇದ್ದಾರೆ ಅವರು ಇಲ್ಲಿ, a charged particle is moving on a circular path with a velocity v in a uniform magnetic field B. If the velocity of the charged particle is doubled, so velocity ಏನಾಗ್ತಾ ಇದೆ double ಆಗ್ತಾ ಇದೆ and the strength of the magnetic field is reduced to half, then what happens to the radius? Okay, so for that reason whatever the formula is there, illen equation 1 nan formula tagondidini, alle en ಮಾಡ್ತಾ ಇದೀನಿ, I am substituting, keeping m as it is, the velocity is becoming twice, ಮತ್ತೆ q ಅದೇ ರೀತಿಯಾಗಿ ಇಟ್ಟು the magnetic field is reduced to half. ಹಾಗಾದ್ರೆ ಇದೇನಾಗತ್ತೆ 4 2 ಇದು ಮೇಲ್ಗಡೆ ಹೋದ್ರೆ 2 into 2 4 ಆಗತ್ತೆ, 4 mv divided by qb ಅಂತ ಆಗತ್ತೆ, ಹೌದಾ? So whatever mv by qb is there, this is your initial radius. So it becomes 4 times of the initial radius. That is option B is the correct answer. Option B is the correct answer. C. Yes, is it clear? The next question, an electron of energy 1800 electron volt describes a circular path in magnetic field of flux density 0.4 Tesla. Of the path is q value ಕೊಟ್ಟಿದ್ದಾರೆ, mass of the electron ಕೊಟ್ಟಿದ್ದಾರೆ. What you need to calculate here? You need to calculate the energy is 1800 electron volt, describes the circular path of the magnetic field. Again, the radius value you have to calculate. So how to do this? That is, the radius is equal to mv divided by bq, or electron anta ಹೇಳಿರೋದ್ರಿಂದ ನಾನು ಇಲ್ಲಿ e ಅಂತ ಕೂಡ ತಗೊಳ್ಬಹುದು instead of q. mv divided by b into e, so which is equal to m divided by b into e. The velocity, I can substitute it as what? 2e divided by m. So therefore this is equal to under root of 2 me, this divided by, it is b into e. Okay, ನೀವು ಈಗ ಬೇಕಾದ್ರೆ value substitute ಮಾಡಿ calculate ಮಾಡಿ and tell me the answer. Option B, yes, option B is the correct answer. Two, mass of the electron is given. The energy value is 1800 electron volt ಅಂತ ಇದೆ, ಅದನ್ನ joules ಅಲ್ಲಿ convert ಮಾಡ್ಕೊಳ್ಬೇಕಾಗತ್ತೆ students. So R is equal to, it is under root of 2 into 1800 into 1.6 into 10 raised to minus 19 into 9.1 into 10 raised to minus 31. This idu whole divided by root ಹೊರಗಡೆ ಬರಬೇಕು, b into e. So that is 1.6 into 10 raised to minus 19 charge of the electron into 0.4. This you need to simplify. See. So ಇದನ್ನ simplify ಮಾಡಿದ್ರೆ ನಿಮಗೆ option B ಬರುತ್ತೆ. Yes, you can see the solution here. Copy down the solution. We will see one more question and we will go. I'll tell you the formula list once again. It's completed. Kavya, Malika, June. Okay. The last question. Two alpha particles have a ratio of their velocities as 3:2 on entering the field. If they move in a different circular path, then the ratio of the radii of the path is. The ratio of the radii of the path is, they are asking. What we can do here, that is nothing but QVB is equal to mv square divided by r. So therefore r is equal to, it will be mv divided by qb. ಹಾಗಾದ್ರೆ ಏನಾಗುತ್ತೆ, ರೇಡಿಯಸ್ ಇಸ್ ಡೈರೆಕ್ಟ್ಲಿ ಪ್ರಪೋರ್ಷನಲ್ ಟು ವೆಲಾಸಿಟಿ ಅಂತ ನಮ್ಗೆ ಈಗ ಗೊತ್ತಾಯ್ತು ಇಲ್ಲಿ. therefore ನಾವೀಗ ಏನ್ ಮಾಡ್ಬೋದು, RA divided by RB is equal to VA divided by VB. Yes, the radius is 3:2. ಇದು ಏನಾಗುತ್ತೆ 3:2 ಅಂತಾನೆ ಆಗತ್ತೆ, because it is directly proportional. Yes, option B is the correct answer. Yes, copy down. I'll tell you the formulas once again. Okay, all the formulas you want it or only the few? So see, the first one, that is due to the magnetic force on the charged particle, is given by QVB ಅಥವಾ QVB sin theta ಅಂತ ಬರಿತೀವಿ. The charge for the charged conductor ಅಥವಾ long conductor ಗೆ the equation becomes IBL ಅಥವಾ IBL sin theta ಅಂತ ಬರುತ್ತೆ. This is for the conductor, ಮೇಲ್ಗಡೆದ್ದು for the magnetic force due to the charge, magnetic force due to the conductor. ಆಯ್ತಾ? Then after this we discuss the this one, Lorentz force. So Lorentz force andre ಏನು students? Lorentz force andre it is due to the electric force plus due to the magnetic force. ಹಾಗಾದ್ರೆ ಇದರ expression ಏನು ಬರುತ್ತೆ? The expression will be Q common ಆಗಿರುತ್ತೆ. Therefore it is E plus V cross B. E plus V cross B. This is the electric field plus this is the magnetic field. Magnetic force, electric force and the magnetic force. So these are the three formulas. The next one, when the charged particle is moving in a circular path, ಆವಾಗ ನಮಗೆ ಕೆಲವೊಂದಿಷ್ಟು expression ಬರುತ್ತೆ. When the charged particle is moving in a circular path, its radius is given by, ಆ circular path radius ಅನ್ನ mv divided by qb ಅಂತ ತಗೊಳ್ತೀವಿ. ಮತ್ತೆ mass into velocity is nothing but momentum. So this is momentum upon qb, which is also is equal to momentum in terms of kinetic energy is written as 2mk divided by qb ಅಂತ ಕೂಡ ಬರಿಬಹುದು. Then the time period is given by, so ಇದು radius ಆಯ್ತು. The time period is given by 2 pi m upon qb ಅಂತ ಬರುತ್ತೆ. Frequency ಏನಾಗುತ್ತೆ ಅಂತಂದ್ರೆ frequency will be reciprocal of the time period. Frequency will be reciprocal of the time period. Therefore it is qb divided by 2 pi m. Similarly, the kinetic energy in the circular orbit, it is given by the kinetic energy it is half mv square ಅಂತ ಇರುತ್ತೆ. There we can substitute the value of velocity. So before taking the kinetic energy, take the angular velocity. It is given by qb upon m and the kinetic energy is given by, this is equal to q square b square r square divided by 2m. Q square b square r square divided by 2m. Is completed. This is for the circular path. This is for the circular path. Completed, students? So if the charged particle is moving in a helical structure, ಆವಾಗ ಏನ್ ಬರುತ್ತೆ ಅಂತ ಅಂದ್ರೆ the expression is yes, take down. If it is moving in a helical path, then the radius is given by mv sine theta divided by qb. mv sine theta divided by qb. Similarly, the time period is given by, it is 2 pi m upon qb. So we can take in terms of velocity also, the formula becomes 2 pi r divided by v sine theta. Idu helical path ige ಆಯ್ತಾ. ನಾವು ಮುಂಚೆ ಬರ್ದದ್ದು for the circular path. This is for the helical path. So reciprocal of the time period is nothing but what? It is the frequency. So formula can be written for the frequency also. So you complete that. Here I'll write due to the Biot-Savart law barita idini. So according to Biot-Savart law, the dB is given by dB is equal to mu naught upon 4 pi I dl cross r divided by r cube. ಅಥವಾ ನಾವಿದನ್ನ mu naught upon 4 pi I dl sin theta upon r cube ಅಂತ r square ಅಂತ ಕೂಡ ತಗೊಳ್ಬಹುದು. And if you want the value of mu naught upon 4 pi, mu naught upon 4 pi will be 10 raised to minus 7. Yes, complete this. Then tomorrow we will continue. Okay, students. So copy down. Tomorrow we will meet. Thank you.